Hi guys, here's I-4. So f of x is a continuous function with selected values shown in the table below. Find the trapezoidal approximation for the integral from 0 to 13 of f of x using the 5 subintervals indicated by the table. Okay, so here's this table, and we're going to use trapezoids instead of rectangles. So a trapezoid in our case is going to look like this. And we'll talk about its area. Normally, when you see trapezoids, like in geometry class or just when you recognize them, they look like this. So you've got these two parallel sides, and the two parallel sides are the bases. There's two bases. And then the height is like the vertical distance between those horizontal parallel sides, if you look at it that way. And then, there's this like oftentimes a slanted side here. Although the bases of a trapezoid could be equal, in which case it would be a rectangle. But so anyway, so yeah, we just want to be careful that we're looking at, so what was previously the base of our rectangles we were using is now the height of our trapezoids. And what were used as the heights of our rectangles are now the bases of our trapezoids. Okay, so just be careful. And so you want to take the points that you're given, sketch them nicely, and connect them because the function is continuous, and the integral would not be defined otherwise. And then you are ready to draw your trapezoids. So the first trapezoid, this is its height, okay? And then the bases, you go from either end of the subinterval up to the graph. Those are the bases. And then you connect them, all right, for that like slanted side. Okay, so there's that. Okay. All right, now let me just like slowly do that first area. And I'll write the sum down here. So the integral from 0 to 13 of f of x is going to be approximately, and we're going to have 1, 2, 3, 4, 5 trapezoid areas here. And you could do it differently, guys. Like you could kind of do the whole thing in your calculator without writing anything down. That some people might want to do that. I find it easier to follow my work. I don't know. I just like to have my work written down. My calculations. I like to have something written down for calculations like this. Okay, so the bases are 4 and 9. So 4 plus 9. The height is 2, and then you divide by 2. Okay, so that's for that first one. Now let me draw the rest, and then I'll just like quickly write that out for the rest of them. Here is the height, base 1, base 2, connect. That's the second trapezoid. Height, base 1, base 2, connect. That's the third trapezoid. Here's the height, base 1, base 2, connect. Height, base 1, base 2, connect. Okay, and guys, as you can see, trapezoids give a better approximation than rectangles. But rectangles' formulas are easier to work with, so that's why eventually we're going to be just using a bunch of rectangles. But trapezoids are pretty good. If you want to use an infinite number of rectangles, which we're going to be using in the future by way of a limit, if you want to use an infinite number of shapes, then rectangles are great. But if you are using like a finite number of shapes, like 5, trapezoids are really nice. Give a pretty good approximation. All right, so that's the first trapezoid. Plus, for this second trapezoid, the base 1 is 9, base 2 is 14. So 9 plus 14. The height this time is 1, and you divide by 2. All right, for the third one, 4th, 5th, okay. All right, I'm just like setting that up. Okay, the third one, 14, 27, and and then the height is 4. And then this one, 27 and 35. And then the height, again, is 4. And then this last one, 35 and 41. And then the height is 2. Okay, and you plug all that into your calculator, and you could do the calculations differently than me as long as you're confident. And when you plug it in your calculator, you get 306.5. Okay, 306.5. I'll just go like that.